Minecraft. Have you ever wondered how the angle of the rain streaks on the side window of your car changes as the car accelerates? Me neither. So my friend here, Frederick, needs help with his engineering mathematics project. So let's read the question aloud here, shall we? A student is a passenger in a car accelerating away from the traffic lights on Orchard Road. A heavy thunderstorm is in progress. The student notices that over a time of 2 seconds, streaks made by the rain on the side windows change angle from 45 degrees with the vertical to 60 degrees with the vertical. The student knows that the acceleration of the car is about 1.3 meters per second squared and assumes that the rain is falling vertically with uniform speed. Because the student has very recently been revising for engineering mathematics, he is able to use his observations and assumptions to make an estimate of the speed of the falling rain. Find the speed in meters per second. What the Frederick? I can't help you out, man. What is this? What is this, bro? Who do you think I am? You think I'm the world's renowned astrophysicist Neil deGrasse Tyson?
Hi Aqief, how may I help you?
Hey, Neil? Yeah, my friend Frederick here needs help with his engineering mathematics project. I sent you a file. Can you just help us with the question?
This is easy, you dumbbell. Picture this. Frederick is riding in a car accelerating away from the traffic lights on Orchard Road during a heavy thunderstorm. The car accelerates at 1.3 meters per second square. As he looks out the side window, he notices the angle of the rain streak changes from 45 degrees to 60 degrees with the vertical over a span of 2 seconds. Now, why is this happening? Rain is falling vertically at a constant speed, but as the car speeds up, the horizontal component of the rain's apparent motion changes. At 45 degrees, the horizontal and vertical components of the rain's motion are equal. When the angle shifts to 60 degrees, the horizontal component is increasing relative to the vertical. By understanding these angles and knowing the car's acceleration, you can use trigonometry and kinematics to estimate the speed of the falling rain. This scenario beautifully illustrates how real-world observations can be dissected with mathematical principles, revealing the hidden mechanics of our universe.
I think I got it. Thanks, Neil. Now, if you still didn't get it, let me break it down for you. So now, as you can see, Frederick is in a car, and his car is moving from point A to point B. We don't know his initial speed, neither do we know his final speed. But we do know that he's accelerating from point A to point B at 1.3 meters per second squared. Okay? And in between point A and point B, he's traveled at about 2 seconds. So as the rain's falling down, it's hitting the side of his car, the side window of his car, and the angle is changing from 45 degrees to 60 degrees to the vertical. So yes, it's moving vertically down. We don't know what the rain speed is, we don't know what the initial car speed is, and we don't know what the final car speed is. So let's try and simplify it in a diagram. So you can see that the rain speed is going down vertically, then the horizontal speed is going there, so they're about 90 degrees. Now, we know that at point A, when he first started out, before accelerating, the angle of the rain streaks was about 45 degrees. And then afterwards, it went to 60 degrees to the vertical. So with that, we can look at the initial speed first. So when we use tangent 45 degrees, okay, tangent is when we remember tuakaso, so tangent opposite over adjacent. So the opposite is the initial speed, the adjacent is the range speed. So tangent 45 degrees is initial speed over the range speed, which is equal to 1. So in that case, we now know that the range speed has to be equal to the initial speed of the car. So now we do it for the final speed. Okay. So when the angle changed from 60 degrees, tangent 60 degrees, opposite over adjacent, final speed over the range speed, we get tangent 60 degrees, which is 1.732 or to 3dp. So now we know that once we move the equations here and there, we can find out that the final speed is equals to 1.732 multiplied by the range speed. So it's 1.732 times the range speed. So that is equal to the 1.732 of the initial speed, as they're both the same thing. So now we put them all together. Now we know that acceleration is 1.3 meters per second squared. We know that the time taken from point A to point B is 2 seconds. Okay, and knowing that acceleration is equals to the final speed minus the initial speed over t, we can rearrange that and multiply a and t together, and we can find the final speed minus initial speed. So we put in the values together. Okay, and we know that the final speed is equal to 1.732 times the initial speed. Okay, we can see that these are the same unit. Okay, so 2.6, 1.3 times 2 is 2.6, and then we get 1.732 of the initial speed minus, we can see that this is 1 unit of initial speed. So that's why we get 2.6 equals to 0.732 of the initial speed. Now we rearrange this equation once again. We can get 2.6 divided by 0.732, okay, which is equals to the initial speed, which is also equals to the range speed, which is equals to 3.55 meters per second to 2 decimal places. And that is how you use Minecraft, Neil deGrasse Tyson's AI voice, as well as Canva. Just to show how kinematics work with angles and speed, and all you need to do is just make 2 triangles, one small, one big, which took me 3 weeks to figure out. But yeah, that's my video. Hope you all enjoy it. I'll see you all when I open my eyes. Bye bye.